Hello everyone, we are back again with our lecture series on database management systems EC703C. So this is the fourth lecture of the series, and today our topic will be SQL, structured query language. This is a very important topic. So one thing I want to uh, tell you before you start moving to learn SQL, that you need to install some RDBMS package in your laptop or PC, whatever you are having, and you need to practice running these commands that we will learn today. By that way, it will be easier for you to grasp the functionalities and the strength of SQL. Okay, so these are the outlines of today's lecture. So we will first see the overview of the query language, SQL query language, what it is about. Then data definition, basic structure of a query in SQL, additional basic operations, set operations, null values. So all kind of operations and all kind of data types that are available in SQL, we will learn today. To begin with, SQL, it's nothing but IBM SQL language, which was developed as part of System R project at the IBM San Jose Research Laboratory. So then it was renamed to Structured Query Language. So it was nothing but IBM SQL language, which was developed by IBM. Then it was renamed Structured Query Language. It has many versions depending upon the year. SQL 86 to SQL 2003. Now, because of these different versions, it is very important that while you install a RDBMS package like MySQL or Oracle in your computer or laptop, then please check the version of the SQL that you are using, because depending upon the version, the commands, the query commands that we will learn varies. So some commands supported by SQL 92 may not work properly in SQL 2003 version, right? So before installing a package, just check what version of SQL it is using. Now this language has these parts. We will see that how to use these parts. Just move forward. DML, last day we studied what is it. That is data manipulation language. So inserting data, deleting data, then modifying data in the database. These things we do using DML. If you want to set any integrity constraint means you want to put a check on the values of some attributes. Then also you need DDL, data definition languages. View definition, which users will be able to view which part of the database can be managed by DDL. Transaction control, if multiple transactions are happening parallelly in SQL, then how we are going to control them. Then one very important part, embedded SQL and dynamic SQL. So we have discussed that we can embed SQL in general purpose programming languages. So embedded SQL and dynamic SQL, they define how to embed SQL statements and call them from general purpose programming languages like Java or C++. And finally, authorization. So it is about specifying access rights to relations and views. That means higher priority viewer will be able to see all the results, but a user with minimum privilege or minimum priority won't be able to, is not authorized just to see all the available records or all the available views. So these are the SQL different parts: DML, manipulation language, integrity constraints, view definition, transaction control, control, authorization, etc. We will now take some instructions from both DML and DDL, and we will look at the examples, and we will get a very fairly good idea about how SQL parts works. So this is the data definition language. So just to recapitulate, the SQL data definition language allows the specification of information about relations, that means the tables, including the schema for each relation. You remember the schema. Schema is the logical structure of any relation. The types of values associated, that means the data type of each attribute. Integrity constraints, the set of indices to be maintained for each relation. Security and authorization, physical storage structure. So these are the things that you can manage through DDL of SQL. Now this is important. These are the data types or domain types of attributes that are supported in SQL. So first it comes our very own char variable, that is character in nature. So any data type you can specify it by char. Inside bracket n is the size that you are saying. That if you are saying name is one char 50 variable, then name is a variable which can accept strings made of characters up to length 50. Okay. Another variant of char is varchar n. So this is nothing but variable length character strings. So this varchar and char, we will see how they are interrelated when we will take some examples. All the other data types like int, small int, numeric, real and double, float, I guess all of you now have a idea about these kind of data types, which we have already used in some popular programming languages. So by not wasting our time, we will just move towards our next slide, which is the first DDL, that is create table construct. So that is the beginning, because first you need to create a relation. You need to learn how to create a relation. And to do that, the command is create table. So see, look at the structure of the command, create table R. R is the relation name. A1, D1, A2, D2, A's are for attributes, D's are for data types. So here, create table R, you can have n number of attributes and data types. Then you can have constraints for each of them, each of the attributes, right? So one example, our previous day data example about relations. So remember, there was a table named instructor, right? So if you want to create, and the instructor relation had 4 attributes. So see how it is being done. Create table instructor. So create table, then you write the relation name, then you specify the attributes and their corresponding data types. So ID, name, department name, and salary were the 4 attributes, and you also specify their corresponding data types. So ID is char 5. So ID can support length up to 5. Name is variable character 20. So that means your name length can be, someone's length can be 10, someone's 15, someone's 20. That will be adjusted by SQL because you have specified the data type as varchar. Department name same varchar. Salary as it is a numeric value. So we will use numeric data type where fixed point number with user specified precision of p digits with d digits to the right of the decimal point can be registered. So here salary is numeric 8,2 data type. That means 8 figure salary with up to 2 decimal points at the right hand side is allowed. So this is how you create a table. You write the relation name, you write the attributes, and finally for each attribute you write the corresponding data types. Okay. Now how to put integrity constraints. So what are integrity constraints? As we have discussed earlier, that integrity constraints on attributes means that you want to put some checks on their values. So integrity constraints, primary key, foreign key, not null. These three are the most popular integrity constraints. So for the instructor table, you can see the example. After writing the create table instructor and specifying the attributes and the data types, we are writing primary key within bracket ID. I hope you haven't forgotten what is primary key and foreign key. We have spent a lot of time in last lecture for discussing this. Primary key ID, that means ID is a unique value. ID can be used to uniquely locate any particular tuple in the relation. So we are specifying primary key ID. That means ID, we are putting a constraint that this ID should be unique for every instructor. And we are writing foreign key department name, references department. So department was another relation, and in that relation, department name was the main primary key. Right? So we are writing foreign key department name, references department. So department name is a foreign key. So while putting value in the department name attribute, we need to remember that it is being directly referenced by the department relation. Good. So this is how we put integrity constraints. For some other relations also, create table student. It was see here for create table student, we are writing ID varchar 5, name varchar 20, not null. So this is an example of putting another integrity constraint. So you are telling that name cannot be null. Name can never be null. It should, whenever you are putting values in your relation or in your tables, then this field cannot be left blank or empty. That is like putting another integrity constraint over the name attribute. Here also we are uh, taking primary key ID and foreign key department name. The next example, create table text. See here we are having 6 attributes and we are having multiple primary keys. Right? We are also having multiple foreign keys. Foreign key ID is referencing student relation, but foreign key course ID, section ID, semester and year, they are referencing a different relation named section. So this is possible that your relation can have multiple foreign keys, which are in turn are referencing different relations. Like here, the ID foreign key is referencing student relation. Course ID, section ID, semester and year are referencing section relation. Now, how we put values in the tables and how we delete them, how we insert values, how we update the values. That is our next goal. So first command is inserting values. So the command is pretty simple. Insert into instructor values. Now you within bracket you write the values. All the strings will be inside a single quote. So the first value is 10211. That means the ID, then name, then department name, then salary. So ID is 10211, name Smith, department name biology, and salary is 66,000. Okay, delete, it is used to remove all the tuples. If I write delete from student, then all the values that you have inserted will be deleted. Drop table, this command is used to delete the whole relation itself. That means when you are writing delete, then only the records, the values are being deleted. But when you are writing the drop table command, then actually the total schema, the logical schema of the relation will be deleted from your database. Then alter table. Alter table means if you want to change the update the schema, suppose for instructor, you want to add another attribute named contact number. Okay, so you can do that using alter table command. You can even remove attributes. Suppose I don't want to show or store the salary value for each instructor, then we can drop the salary part from the instructor relation. So alter table is used to make changes in the schemas of the relations. This is a basic query structure of SQL language. So look at it. This is select from where. I guess those who have brushed up relational algebra, we have already seen select and from clause being used there, and they works in the same way in SQL 2. So select A1, A2, N, that means selecting the attributes. From R1, R2 means from the table names. Where P is a predicate. P is a predicate means P is some condition. So we will look at some example. Suppose the question is finding the names of all instructors. So I want to, from your institute, I want the name of all instructors to be displayed. The command is select name. Select, then the attribute, select name from relation name, that is instructor. So select name from instructor will first go to the instructor relation, then will fetch all the names of the instructors and will print them. Okay, so that is the select clause. It lists the attribute desired in the result of a query. So you write select, then the attributes you want to select, you want to print the desired attributes. Then you write from the relation where you will get the attribute values. So just to say elaborately, if we write, if you can see that there are duplicate values in the relations because SQL allows them. So if you write select department name from instructor, then as in the instructor relation, there are multiple instructors who belong to the same department. So the result will look like this. The table see here, if I write select department name from instructor, I will get multiple department names. computer science. This will be printed for all the faculties who works in computer science, music, physics, same for everyone. Now, if you want to remove the duplicates, that is, I only want the department names. I only want to see what are the departments available in this college. Then I will use the distinct keyword. So to remove the duplicates, we can use distinct keyword. So the command is like select distinct department name from instructor, and this will give you the result as it will remove all the duplicates, and computer science will be printed only once, finance, history, biology, music, all of these department names will be printed only once. All the duplicates will be removed. Now, if you want all the duplicates, then your command will be select all keyword, select all department name from instructor. Then you will get from instructor relation all the department names. That whole column will be printed, right? We can use an asterisk in the select clause which denotes all attributes. So select star from instructor, star asterisk means that select all the columns from the instructor relation and print them. Okay. So if you want all the columns which are available, with all the attributes which are available in the relation, then no need to write all of them. You can just write select star from instructor, and that will be enough. Next, an attribute can be a literal with no form clause. An attribute can be uh, any numeric value, select 437 or select A. So these two things, they don't have much practical use. So we will move to the next topic. The select clause can contain arithmetic expressions involving the operation plus, minus, divisions, multiplications. Okay. So the query is the select ID name comma salary divided by 12 from instructor will fetch all the salaries and make the division operation by 12 and will print it. So it will be like select ID name salary by 12 as monthly salary. And that is the use of the rename clause. So if you are writing select ID name salary by 12 as monthly salary is a new variable, and monthly salary variable will replace salary by 12 this attribute name. So this is nothing but renaming an attribute name in your SQL command. You can rename anything. You could have written SQL ID name as official name or a nickname. So that will be like renaming the name attribute to something else which can be of your use in practical purpose. So after the select clause, we will move towards the where clause. The where clause specifies conditions that the result must satisfy. So this where clause is used for putting filters to the results that the select clause fetches. So why inside the where clause, we will write the selection predicate of the relational algebra. Like if our query is to find all the instructors in computer science department, then the query will be select name from instructor. This is the first part. So this will give us all the names of all the instructors. Then I'm writing the selection predicate where department name equal to computer science. So department name is an attribute. So I'm writing where department name equal to computer science. So then from the relational, from the table, only department, only the instructors who works in computer science department, their names will be shown. Okay. This is how we use where clause. Then you can also use and, or, and not operators. And in and or not, you can have less than equal to, greater than equal to, all kinds of uh, logical connectives, right? So just take an example to find all instructors in computer science department with salary greater than 70,000. So in the previous instruction, it was select name from instructor, where department name equal to computer science, and so we are taking one logical connective, and salary is greater than 70,000. So we are putting two selection predicates. First, all the names which belongs to department name computer science will be fetched. Then over them, the next predicate, salary greater than 70,000, will be fired, and we will only get those names here. Cats and brand will only get those names whose salary is more than 70,000 and whose department is computer science. I hope it's clear. Next is the from clause. From clause is equivalent with the Cartesian product that we have studied in relational algebra. So it lists the relations involved in the query. Like if you want the Cartesian product, I guess you remember what's the Cartesian product. If you write find the Cartesian product instructor cross teachers, then you can write select star from instructor. Okay, I guess the star symbol is not supporting here. So this question mark here, it was a star symbol. So select star from instructor comma teachers. It will generate every possible instructor and teachers pair, just like your Cartesian product example. So it will generate every possible pair from instructor and teacher. So that means it will take one tuple from instructor relation and it will merge it, generate all possible pairs from the teachers relations tuples. Okay. And if there are any common attributes, then the attributes in the resulting table will be renamed using the relation name. Like we know that in instructor and teachers, in both the cases, we are having one common attribute, ID. So in the resultant table, we will have two attributes, one named instructor.id, another named teachers.id. Those who have forgotten Cartesian product, please refer to previous lecture. This is one example. So we are asking the query that find the names of all instructors who had taught some course and the course ID. That means print the name of all instructors from the database who have taught some course, and also print the course ID that they have taught. So how you can get that? Now you know that from clause can be used to merge or join two relations, which generates every pair possible. So I am writing select name comma course ID from instructor and teachers, where instructor.id equal to teachers.id. And in this way we will find all the instructors names and the course ID that he or she is teaching. Another example, find the names of all instructors in the art department who have taught some course and the course ID. So we are putting three constants here. Not only we need the names of the instructors and their course IDs, we also need to classify the result only for those instructors who works in the arts department. So how we are going to do it? We are writing select name comma course ID from instructor comma teachers, the Cartesian product, where instructor.id equal to teachers.id. Okay, so that is the predicate, and the second predicate, instructor.department name equal to art. So only those instructors whose department name is art will be selected, and their corresponding course IDs will be printed. Now, another important operation is the rename operation. Suppose the query is finding the names of all instructors who have a higher salary than some instructor in computer science department. So understand the question that I have the details of the instructors, their name, ID, department and salary stored in instructor relation. Now I want the names of all those instructors who have a higher salary than anyone else from the computer science department. So that means inside the instructor table, instructor relation itself, we need to check the values. So we are writing select distinct. Distinct is used for removing the duplicates. So select distinct t dot name from instructor as t, instructor as s. So we are making two copies of the instructor relations, one named as capital T, another named as capital S. And now we are having two copies of the same table. So we are now comparing where T dot salary is greater than S dot salary. So we are taking each salary from T relation and comparing it with S relation salary, where S dot department name equal to computer science. Because we need to check, look at the query, we need to check that all those instructors' salary should be higher than some instructor in computer science department. So we are putting two predicates, T dot salary is greater than S dot salary and S dot department name equal to computer science. Okay, so first for the S relation, only those instructors' names will be selected who belongs to computer science department. So in the instructor relation named as S, there you will have fewer records of only those instructors who belongs to computer science department. And in the capital T relation, you will have the records of all the instructors. Now you are comparing all the instructors' salary from the T relation with salaries from S relation, and you are printing T dot name. You are fetching T dot name of the faculties from T relation, and that will definitely give you the names of the instructors who have a higher salary than some instructor in computer science department. Yeah. So keyword as is optional. So from instructor as T, instructor as S, you can just drop the as keyword. Now another again, just to make you cautious, that these comments varies from version to version. So maybe in some version, if you drop the is as comment, it will not work. Just keep it in mind. Now there are different string operations. String operations are used for matching strings given inside your query. Okay. The two operators which are used is like, percentage, and underscore. The operator like uses patterns that are described using two special characters, percentage and underscore. Let us see, percentage character matches any substring and underscore character matches any character. So suppose the query is find the names of all instructors whose name includes the substring DAR. So I want to print the name of all instructors whose name includes DAR. Somewhere in their name, this substring DAR is present, like Shamaddar, right? So I'm writing the comment as select name. I want the name, select name from instructor relation, where name like. So like operator is used for string operations. Like inside the code, percentage DAR, percentage single quote. That means where name like, percentage DAR, percentage. So somewhere inside the name, if you are having DAR, before DAR you can have something. The first percentage will take care of that. The percentage character matches any substring. After DAR you can again have some substrings. The second percentage will take care of the latter part of the string. And if the name has DAR, this substring, anywhere inside it, then it will print those names. So we are using like and percentage operators here to find the names of all instructors whose name include the substring DR. Okay. Now, while doing string operations, you need to remember something, that patterns are case sensitive. Like intro percentage matches any string which is beginning with intro, because the percentage is there as the last part of the substring. So first intro will be matched, then it will look for anything afterwards, because percentage means any substring. Percentage means comp as a substring anywhere in between a string. 3 underscore matches any string of exactly 3 characters, because you remember underscore means the character, one character. So if you are putting one underscore, it will match with any character. Okay, so this is how we do string operations. Definitely we need to practice a lot, and we need to do it in our lab sessions. In our lab sessions, that is EC 793C, we will deal with SQL in a detailed manner, and there we will do a lot of practices. We will see a lot of problems and how to solve those problems using the commands that we have learned today. So this is it for today. We have a lot of other things in SQL that we will continue in our next lecture session. Thank you.